Okay. To take a base 10 number, we're going to convert from base 10 to base 10, which doesn't make any sense because it's not going to convert at all, but it's just going to show you how the base 10 system works. So, but once you see how to do it with base 10, you'll sort of have a framework, a model for converting other base numbers, any other base number, into base 10 or into the other number system from base 10. That's more challenging. We'll get to that in a bit. But if it's base 10, we know that our lowest place value is 10 to the 0 or the ones place. I really shouldn't say the lowest whole number place value. We know there, of course, are fractional place values like the tenths place, 10 to the negative 1, the hundredths place, 10 to the negative 2. We're not going to go there for the purposes of time, but we certainly could, and that also works the same for any other base system. So 10 to the 0 power is the ones place, 10 to the first power is the tens place, and 10 to the second power is the hundredths place. And so if you have a 5 in the ones place, you have 5 ones. 5 times 1 is 5. If you have a 7 in the tens place, 7 times 10, 7 tens is 70. And if you have a 1 in the hundredths place, 1 100 is 100. So you have 170 and 5. So you have 175. It might seem like a little bit of a waste of time to do that with base 10 because we ended up back where we started, but I want you to see how to use the table to consider a different base system, but first using our own base system to understand it better. This subscript, by the way, tells you what base you're in. So if I just gave you a number 175, you would assume it's base 10 because that's what we use is base 10. But if I gave you a number like, let's say I give you this number with a little 2, that would let you know that, oh, wait a minute, that's not 1,000, that's actually 8. You might say, well, how is that 8? This is binary. We're going to learn that tomorrow on Friday. But the subscript would tell you the base number system. 1,000 in base 2 equals 8 in base 10. You'll experience that tomorrow. But just know that the subscript indicates the base number. All right. The X-Mania number system uses base 6. We've already explored and discovered and understood that. And so, that's unfortunate. I wish that wasn't there. But I need that. All right. Pardon me while I make some on-the-fly adjustments here. I would like you to ignore this. We're going to do it. We're going to do that same thing, but we're going to do it with this number. This is the one that's on your notes. We learned that this is X-Manian for 1. Kind of looks like a 1 inside the circle. This doesn't look anything like a 2, but this is their this is the way they represent 2, a circle with a horizontal line. They have a diagonal line going left to right. That is their 3. Diagonal line going right to left. That is their 4. And the X is their 5. Their 0 looks very much like our 0. It's just a circle with nothing in it. The X-Mania number system uses base 6. We might think, well, why base 6? It only goes up to 5. Well, our numbers only go up to 9. You get 0 through 9. 10 is not a symbol. 10 is 2 symbols, 1, 10, and 0 ones. So base 10, the highest number, the symbol representing the highest single-digit number will always be 1 less than the base. So if we have base number place value system using base 6, the highest value you can represent with a single digit will be 5. If you want 6, then you're in the 6's place, and you have a 1 and a 0. 1, 6, and 0. It looks like 10, doesn't it? Our 10 is 1, 10, and 0 ones. Their 6 is 1, 6, and 0 ones. So 6 and 0, 6. 10 and 0, 10. All right. In order to convert from an X-Manian number to base 10, you, instead of writing the number horizontally, like we would with a horizontal place value system, their alien number system works vertically, starting with the lowest value, which I should probably give myself a bit more room for some reason that I'll show you in a second. This symbol represents, to us, a 3. This symbol is a 1 in our system, and this symbol is another 1 in our system. But they're not counting 3 1s, 1 10, and 1 100. They're counting 3 1s because 6 to the 0 is 1, and 1 6, and 1 36, because this is base 6. So the place values are based on 6, base 6. 6 to the first power, 6 to the second power. Okay, if they have 3 1s, that's 3. 3 times 1 is 3. If there's 1 6, that's 6. If there's 1 36, that's 36. And so the base 10 value would be the sum of these. 42, 45. This is 45 in base 10.